All right, module 21.2. We're talking about the normal distribution. This is day 1. We'll talk about z-scores tomorrow. So we use normal distribution to find the percent of data under certain conditions. This is an example that you can write down, but we need to talk about what a normal distribution looks like. We talked yesterday that it was meant like it was a bell curve, but we need to actually look at what it is. So when we start talking about it, the average, the mean goes in the middle. That's the average. That should be the highest point of values. From there, we start to go out. So if you're looking at your data, and we want to know how far apart, the standard deviation tells us how far apart the data is from the mean. Okay, so the mean is the center of everything. So if we go out 1 standard deviation on each side of the mean, so 1 standard deviation on each side of the mean, we capture 68% of our data. So 68% of our values are going to be within 1 standard deviation from the mean. And that standard deviation is going to be different values depending on your data. Now, we go out another standard deviation. So this is the mean plus 1 SD. This is the mean minus 1 SD. So this is your standard deviation here. If we go out 1 more, either direction, and I'm trying to kind of color code this. So let's go here and here. So we're in the purple. So we're going out 2 standard deviations. So this is x bar plus 2 SD, x bar minus 2 SD. So if we go out 2 standard deviations from that mean, we're going to capture 95% of our data. So 95% of the data should be within 2 standard deviations of the mean. Now, if we go out 1 more, let's see, I'll make it taller than our title here. 3 standard deviations means this is x bar plus 3 SD. This is x bar minus 3 SD. So I'm going out 3 standard deviations from the mean. I'm going to actually capture 99% of my data, which leaves a little bit on each end. Now, the nice thing about this, when we look at this, the bell curve from here to here is 50% of our data, and the other 50% is going to be below the mean. So 50% is going to be above, 50% is going to be below. So we can use the mean to kind of break this in halvesies. So when we look at the orange section, it's 68%. That means there's 34% on each side. The purple, now you got to kind of do a little math here. 95 minus 68 is 27%. And then 27 divided by 2, because we're splitting it in half, means that this is 13.5%, and this is 13.5%. Now, 99 minus 95 leaves me with just a measly 4%, and when I split 4%, it leaves me 2% on each side. Which also means I have a whopping 1% left from that 99. 1%. And if I take that and I divide it into 2 equal parts, that means 0.5% of my data is over here and 0.5% of the data is over here. So very, very, very small amounts. We're going to use those percentages to kind of help us identify different questions and what percent of men are going to be doing this and what percent of women and what percent of kids and what not. But the thing we're going to focus in on is actually how to draw this when they give us a mean and a standard deviation. So that's what our focus is today. Now obviously, because the mean is different for every set of data, we're going to talk about how to normalize that tomorrow, which means so we can use one bell curve to answer several questions. Alright, so you have this example here that we're going to discuss. Suppose the heights of men 20 to 29 in the U.S. are normally distributed. Ladies and gentlemen, it must say normally distributed for us to be able to use this. with a mean of 69.3 inches and a standard deviation of 2.92 inches. Find each of the following. We want the percent of men who are between 63.46 inches and 75.14 inches. Then we want to find the percent of men who are taller than 72.22 inches. And it's easier than you think. So we're going to get to it. The first thing we're going to do is we're going to draw our normal distribution. So here we go. We start with this. We put the mean in the middle. They told us the mean was 69.3 inches. They also told us the standard deviation was 2.92. So remember, to get our next values, to go one standard deviation this way, I just add my standard deviation. So this is the mean plus one standard deviation. So 69.3, and we're going to add 2.9 to that. So 69.3 plus 2.92 gets added. That gives me 72.22. I'm going to go one more. I'm just going to add, again, to this value, I'm going to add the standard deviation of 2.92. And I get 75.14. And then I'm going to go one more. For that third standard deviation, I'm simply going to add again the standard deviation, that 2.92. So this is 78.06. Now, to fill in the other side, because it's to the left, we're going to subtract the standard deviation. So I start with my 69.3 and I subtract 2.92. I get 66.38. Oops, that looked like a 9. And then again, I'm going to subtract the 2.92, and I get 63.46. And again, I'm going to subtract the 2.92, and I get 60.5, whoops, not 2, should be 5.4. All right, now I'm going to use this to answer some questions. And I want you to remember, here to here is 68%. From there to there is 95%. And from there to there is 99%. So we want to know the percent of men who are between 63.46, here's my 63.46, and 75.14. That's 2 standard deviations. What percent did we say was in this purple? That's 95. So the answer to part A is 95%, plain and simple. B wants the percent of men who are taller than 72.2%. So we want from here this way. So this is going to require us to kind of think a little bit. Remember I told you that each half was 50%, so that's 50% on there. And this little section in here is half of my 68, so that's 34. So to find the answer to part B, I'm going to say that's 100% of my men minus my 50 plus the 34. So that's 100 minus 84, which leaves me with 16% of the men are taller than 72.22 inches. And that's all we're going to work on. We're going to practice drawing it, and we're going to practice using it.